Hey guys, so I couldn't be here today. I'm off at a math meeting, but we need to keep going and keep learning math even when I'm not there. So I made this video for you guys. It's going to take you through some notes. As usual, write down everything that I do. The notes should be pretty straightforward, especially since some of this is stuff that we had last year in Math 7 Honors. So it shouldn't be much of an issue. I'll be back Monday to help with any issues we have. Be good for the sub. If I'm going too fast in the video, just pause. It's a video, so you can pause and write the notes down and then keep it playing. But you do need to have all of this stuff down and at least, try your best on the homework. So with that, you can label this as a new section. This is graphing linear equations, and let's get started. A linear equation is an equation that forms a line when it is graphed. Linear equations are often written in the form ax plus by equals c. And this is called standard form. We need to know that. This is standard form. Okay? In this equation, a is greater than or equal to 0. A and b are not both 0. But one of them could be, as long as the other one is not. And A, B, and C are integers with a greatest common factor of 1. Okay, so an example of this is if I had 3x plus 4y equals 12. Okay, we have greater than or equal to 0. Both of these are not 0. And all three of these are integers. And there are no common factors in them. I can't divide anything out of all three of those. Okay? On the other hand, if I had something like, this, let's say negative 2x plus 4y equals 12. Let's just change that one. So there's a few things wrong with this. This one is a few things wrong with this. First, my a value, the number that is with x, is not greater than or equal to 0. Second, I can divide something out of this. In fact, I can divide a negative 2 out of every part. And if I do that, I get x minus 2y equals negative 6, and that's okay. Remember that the only part of it that has to be greater than or equal to 0 is the number with an x. And we can remember from last year, if we don't have anything with x, there's actually secretly a 1 there, but we don't have to write it. Okay? It can't be in any other form. So let's have some more examples. Here we go. If we have y equals 4 minus 3x, if I can rewrite this in standard form, then it is a linear equation. So let's check. I need to get my x and my y on the same side. So I add 3x, I get 3x plus y equals 4. Okay, I check, that's greater than or equal to 1 or 0. Both of these are not 0, and I can't divide anything else out of it. So yes, this is linear. Okay, this is how we check to see if something is a linear equation, if we can write it in that form. Another example. I have 6x minus xy equals 4. Okay, on this one, this xy tells me that it is not linear. I can't have things like x and y being multiplied against each other. I cannot have any exponents. Okay, but if I don't see any exponents and I don't see x and y multiplied against each other, then I can rewrite it in this form, then it is linear. So this one is not linear because of that. Another example. 1/3 y equals -1. Our instincts tell us that this is not linear, but it actually is, because I could rewrite it like this. 0x plus 1/3 y equals -1. Then I can multiply everything by 3. No, I guess I would just leave it. No, I can multiply everything by 3. And I get 0x equals 1y, plus 1y equals 3. Notice that a is allowed to be 0, which means normally I don't have to write it. But if I change that and I multiply everything by 3, that makes 3/3, which changes to 1. -1 times 3 is -3, and I end up with this equation. Here's my ax plus by equals c. Okay, so some of them are a little bit weird to see. Another one. Y equals x squared minus 4. If I look at this, I see an exponent with the x, so this is not linear. And I forgot to write, yes, linear. Okay, this is something that we did talk about some last year in honors, that some of us might remember. Especially now that I've brought up, like, we can't have it in the bottom of a fraction, or we can't have exponents, things like that. Those are things that we did talk about last year, so hopefully it's coming back to some of us. Okay, next bit of notes. Linear equations have x-intercepts and y-intercepts. These are where they touch. The x-axis and y-axis, respectively. Okay, each linear equation only has one x-intercept and one y-intercept unless it is a very specific case. So let's write only one x-intercept and one y-intercept, except special cases. Okay, here are those cases. If you have x equals a number, so like x equals 4, then there is no y-intercept. If you have y equals a number, like y equals -5, there is no x-intercept. If you have, sorry, that's 3. What am I doing? If you have x equals 0, then every number is a y-intercept. And if you have y equals 0, then every number is an x-intercept. But aside from those, if we can write it in standard form with an a and a b and a c, and none of them are 0, well, a and b aren't 0, then we're good. We only have one of each. Okay? To find intercepts, to find an x-intercept, set y equal to 0 and solve for x. To find a y-intercept, set x equal to 0 and solve for y. Okay, so let's practice finding intercepts. I'm going to take my 3x plus 4y equals 12. To find my x-intercept, I'm going to replace y with a 0. So now I have 3x plus 4 times 0 equals 12. Okay, that gives me 3x. This becomes 0, so I don't have to write it, equals 12. Divide by 3, and x is equal to 4. That's my x-intercept. We'll talk about exactly what that means in a minute. My y-intercept, or rather what to do with it. I replace x with a 0, but I keep the y, and I solve for y. 3 times 0 is 0, so I have 4y equals 12. Divide by 4 on both sides, and I get y equals 3. So here are my two intercepts. This is what we can do with those. If I have my graph, I can find x equals 4, which would be about right here, and plot a point there. I can find y equals 3, which would be about right here, and plot a point there. Then I can draw my line between those 2 points, and this is the graph of that equation. This is the graph of 3x plus 4y equals 12. Okay? And that's really most of what there is to do with graphing. There's one other thing we need to talk about, which is graphing by making a table. Okay, so but before we really get to that, as far as we're concerned with graphing from an x and y intercept, that's all it takes. So we're going to plug in 0 for y and solve for x, get our x-intercept over here. Plug in 0 for x, solve for y, and get our y-intercept over here. Plot both of those points. X is 4, y is 3. And then draw a line between them. Make sure we extend the line on both sides like I did here. The line doesn't just stop. It's not a line segment, it's a full line. Okay? It'll be that way for every single question that we have to use x and y intercepts to graph on. Now, graphing by table. Let's say that I have 2x minus y equals 2. Okay, what I want to do is pick points either for x or y and plug them in. But I'm going to make an x and y table. Here's my x, here's my y, just input output. And this is something that we've kind of done before last year's sum. So if I plug in 0 for x, I want to see what I get for y. So 2 times 0 minus y equals 2. Okay, that becomes nothing, so I just have negative y equals 2. I'll multiply both sides by negative 1. And I get y equals negative 2. So my output is a negative 2. I can plug numbers in for either of them. So I'll put in a 0 for y. Now I have 2x minus 0 equals 2. So I have 2x equals 2. I divide by 2. And I get x equals 1. Okay? The reason I started with these is that's my x and y intercept. I can pick other points, and I'll do one just in case, like x is 3. What about, or 2? What about when x is 2? If I do that, then I get 2 times 2 minus y equals 2. This is 4 minus y equals 2. So I'll subtract 4 from both sides. Y will be equal to negative 2. Then I divide by negative 1 or multiply by negative 1, and I get y equals positive 2. Once you have, I would say, at least 3 points, then we can draw our graph and plot those points. And you can use graph paper so it's more exact. But I'm going to have a point at 1 and 0, about right there. A point at 0 and negative 2, about right there. And a point at 2 and 2, about right there. I draw my line through my points. I'll label my points just to be sure. 1, 0, 0, negative 2, and 2, 2. And I have my graph. So these are really the main things that I'm going to be asking you to do on the homework. I'll upload these entire notes on a Google Classroom and try to attach them, I guess, to this part, to this video as well. But this is going to be all of it, okay? It's either going to be saying if something is or is not linear, which means we can rewrite it in our ax plus by equals c form, and we meet these three qualifications. Or it will be graphing based off of our x and y intercept like we did here, or it will be graphing by table, which is just make a table, plug in points, and plot them and draw your line through. Okay? So our homework, which you can now begin working on, is page 157 to 158, 1 through 11 odd, 12 through 18 all, (23 to 33 odd, and 36 to 40 even. Okay, get started on that. Work quietly. I will be back on Monday and we can talk about this stuff. Hopefully we remember some of it, like the linear stuff from last year. I know that we did in honors talk about graphing linear equations, so hopefully some of this is coming back to us. If not, work quietly, work together, see what you can do. Remember, the answers to the odds are in the back, so if you're not super sure, check there. All right, I will see you guys Monday. Be